Alright guys, today is 5-4 Absolute Value Inequalities, Day 1. I hope your quiz on 5-1 through 5-3 went well. Now, there's only 5 sections in this chapter, so you know a chapter test is coming up here. So start getting your notes together. If 5-1 through 5-3 didn't go well for you, watch the videos over. You could also go to Khan Academy. They have some pretty good videos on everything math related there. Or you can always leave a comment in the video. Don't be like, hey Russell, you suck. Leave a comment in the video like, hey, I didn't understand this part. I will send you a video or post another video to YouTube explaining it. Whatever it takes. You could also send me an email if you don't want to see or show it publicly in the comment section. So lots of different options. Hopefully I will get the 5-1 through 5-3 quizzes pretty soon so that I can grade them. All the work that you did while I was out is all in the process of being graded. So you're going to have a lot of stuff coming back to you. Also, the chapter test that you took before I left is in my room somewhere. I have to find it. So I might be in someday to figure out if I can find those tests. I know I told some of you I'd give you like 10 more minutes on it. I might just end up knocking a couple problems off. So that should be all the groundwork covered. Now, we've learned about absolute values when there's an equal sign before. Now we're going to look at inequalities. But I want to review, what does it mean when there's an equal sign? So first, the absolute value markings are these lines that are vertical right here around the 3. Those vertical lines mean that it's an absolute value. Now the absolute value of a positive number keeps it positive. The absolute value of a negative number makes it positive. Remember, the absolute value of a number of any number makes it positive. Okay? This changes a little bit when we start putting variables in the mix. And I'm going to show you how in example 1. We're going to start example 1 off with what we've done already, just covering when there's a variable inside the absolute value. Before we do example 1 though, today's objective. Today's objective is you will be able to solve an inequality with an absolute value. I don't know why this little box is up here. It's gone now. Example 1. We're going to look at some easy ones first, and then we're going to move into the hard ones as this section continues. It's going to be a 4-day section. So let's make sure we understand the easy one. If it's an absolute value of x equal to 3, you need to remember that there's 2 possibilities. Most people would just say x equals 3. Well, that would say that if x was equal to 3, then I can plug a 3 in here, and that's a true statement. And it is. Absolute value of 3 is 3. But there's not just one answer, because it can also be a negative 3. So your second answer would be x is equal to negative 3. Meaning that if I plug the negative 3 in here, absolute value, I'm just plugging this in for x, goes right in here. Absolute value of negative 3 gives you 3. So it's true for both x equals 3 and x equals negative 3. Okay? The easiest way to remember how to do these is to always set up 2 different problems. Instead of trying to reason through, okay, is it 3 or negative 3? If you set it up like this, as soon as you see the absolute value of a variable equals 3, set it up as the same way, without the absolute values and with a negative. So I'm just taking this 3 and bringing it down, and then I'm doing the negative version of that. If you learn how to do that right now, it's going to make the next problems so much easier on day 2, because we're going to get into more complicated versions of these problems. But you've technically already done this before. I just remember we had a big struggle with it. So I want to make sure that we get it now before we move into the inequalities. We're there. If it's absolute value of x greater than 3, well, then we automatically have to set up our 2 versions of the problem. So we're going to ditch the absolute value sign and leave it exactly the same. But then the other one was to ditch the absolute value and make the negative. Well, technically here we've multiplied by a -1, right? So because this is negative, you have to flip the direction of your sign. So it's x is greater than 3, and and then the other one is x is less than -3. It's an absolute value question. It becomes an or question, which means when we look at the graph, we're going to see that it's not intersecting. It's going to be less than -3 or greater than 3. So they're going to be going in the opposite directions. If it's a less than sign here, remember, we leave it exactly the same. Make it negative. Now we made it negative again, so we have to flip the direction. So it's going to be greater than -3 and less than 3. And you're going to see why it's an and. So it's shading above -3 and below 3. So it's all the numbers that fall within this category. Now, just to prove this is true for these 2 questions, it might not be making a whole lot of sense to you. How could it be less than -3 or greater than 3? Well, if you look at let's choose any number, say 5. We're going to say x is 5. So when we plug that in, the absolute value of 5 is greater than 3. Or, let's say we made it -5. When we plug that in, absolute value of -5, that's just going to give you 5. And 5 is greater than 3. So 5 would be the number that we chose first. That falls up here on the line. And -5 was the second number that we chose. So this is a true statement that x is greater than 3 or x is less than -3. Same thing down here. If we started with saying x is 2, well, then the absolute value of 2 is less than 3. It's 2. 2 is less than 3. You plug a -2 in, then the absolute value of -2 is +2, and 2 is less than 3. So -2 fell in here, so it's falling between the dots. Hope that's making sense to everybody. It's going to take some time to get used to it. Example 2. Absolute value of x is equal to 7.2. Now this is an equal sign, so we know that we are just getting rid of your absolute values. It's equal to 7.2. Didn't change anything. What do we flip? Well, what changes in the second half of the problem? It's got to become a negative 7.2. That's a 7.5. Just like I said, it's got to become a negative 7.2. Mouth was going faster than my hand there. Like it's a greater than. Automatically, you know it's going to be an or. You leave it as greater than 7.2. Or x is, make it negative, and flip the direction of your inequality. Or x is less than negative 7.2. If I want to graph that, perfectly 7.2 greater than shakes this way. Negative goes that way. You can see that it's an or. The middle's left out. Excuse me. If it's a less than, get rid of your absolute value. Leave it the same. Get rid of your absolute value. You're going to make it negative. When you make it negative, you flip. So it becomes an and question. Because it's going to be greater than. And if you don't remember whether it's going to be an and or an or, just graph it first. Negative 7.2. It's got to be greater than this. So it's going this way. It's got to be less than this. So it's going that way. Anytime you see them intersect like this, where this, see how they have that intersection in the middle there? That means it's an and question. Which means you can set it up in this format. And that's your answer. Okay, I want you to do the U tries. Now, you'll see in the U tries, like number 2, we have the less than or equal to sign. Remember, all that changes is whether it's a solid dot or a open dot. Okay, the equal sign one, you don't have to graph. I want you to graph the rest of them, just so you know whether it is a greater than or less than, making it an or an and. As usual, pause the video. Okay, number 1. Absolute value of x is equal to 2. All you do is get rid of the absolute value. You get x equals 2. X equals negative 2. That's it. Absolute value is less than or equal to 6. Get rid of your absolute values. X is less than or equal to 6. Then x greater than or equal to negative 6. Don't know whether it's an and or an or, so I'm going to graph it. It's greater than or equal to this number, so it goes that way. And you can kind of already tell that it's going to be an and. So your final answer would be 6x. So it's just saying x is any number in between those two. See how x is in between the two? And x would have to be any number in between the two. Okay. Number 3. X is greater than 4.2. Well, its absolute value of x is greater than 4.2. So you can automatically make it x greater than 4.2. Then flip your inequality and make it negative. Now if we graph this, if you don't know already, that's 4.2 there, and negative 4.2, just graph it. Open circle going this direction, open circle going that direction. That makes this an OR question. Absolute value of x is greater than or equal to 7. It's going to be x greater than or equal to 7. X, flip your inequality, make it negative. When you graph it, it's greater than or equal to 7. So it's all the numbers that are bigger than or equal to 7. And then you have all the numbers that are less than or equal to negative 7. So it makes it an OR. We'll come back when we wrap this up. X is less than 1. And you have x, flip your inequality, negative 1. When we graph it, 0, negative 1, 1. It's greater than negative 1, so it's going in this direction. It's less than 1, so it's going in this direction. Because we have this intersection where both lines are, it's an AND, which makes it 1, or the positive number, less than sign, x, less than sign, negative 1, telling you x is in between 1 and negative 1. If we look at this, these examples, number 1 doesn't really fit into the category because it's things that we went over previously. But numbers 2, 3, 4, and 5. See if you can draw a pattern in between the two, in between the 4 questions. Our pattern here is going to be, if we look at number 2, that had a less than. It ended up being an AND question. Look at number 5. It was a less than. Excuse me. It ended up being an AND question. Look at numbers 3 and 4. Greater than or equal to. They ended up being OR questions. So the final conclusion we can make based off of these values that we just realized is that you have great OR. Get it? Oh yeah, that's real cheesy, but it works. If you remember great OR, then you can see how your inequalities are going to go. It's going to work like that every time. If it's an absolute value, great OR, then a number, then it's going to make it an OR question. Okay guys, you have your assignment to get started on.